light has a wave nature as well as particle nature. So in this YouTube class you will understand that why light is called wave, or what is the wave nature of light. Okay, how light propagates from one place to another by formation of wavefront. So there is a scientist, okay, so Huygens, so he has proposed this propagation of light by formation of wavefront in the forward direction. Okay, so what is wavefront? The locus of all the particles in the medium which vibrate in the same phase at the same instant of time. That means all the particles, when a light is being lit, okay, it will send light in all possible direction. Now when it is sending light in all possible direction, the particles which are in the same medium, they also vibrate with the same frequency and zero phase difference. Okay, so this one we call as wavefront. Now wavefront, that is wave always travel perpendicular to the wavefront. Wave always travel perpendicular to the wavefront. That means in which direction the light is moving, the rays of light is moving, there only the waves are formed, the wavefront is formed, right? So here we say the point source is, this is the point source. Now types of wavefront, when I say, first let us classify into types of wavefront. Spherical wavefront, this is cylindrical wavefront, and this is a plane wavefront. Spherical wavefront means the point source, the source is point, okay, small point source. So small point source will emit light in all possible direction, okay, all possible direction. So from one point here, it will emit light in all possible direction here. So the wavefront which is formed by this point source is called spherical wavefront. Similarly, cylindrical wavefront means if the source line, so it is in a line source. Okay, so if this is a line source and each and every particle is a source of light here, so this point source, it will emit light in all possible direction. So you will get one here like a circle. Similarly, this point will also circle, and each and every point they will emit light in all possible direction. So like this, when we continue, when we make the same, we will get a form cylinder. So therefore cylindrical wavefront is formed by a line source, spherical wavefront is formed by a point source. And what about plane wavefront? So plane wavefront, when you see a spherical wavefront or a cylindrical wavefront from a far distance, so when you view it, this wavefront from a far distance, like for example this is the point source, right, and you are very far from this point source. So from this position, when you view this light source, a small portion of this wavefront will appear to you as plane wavefront. Okay, I repeat, what is spherical wavefront? Spherical wavefronts are formed due to point source, cylindrical wavefront are formed due to line source, and plane wavefront are formed when you view the spherical wavefront or cylindrical wavefront from a far distance. Small segment of cylindrical or spherical wavefront is a plane wavefront. Okay, so here you see the rays are always perpendicular to the wavefront. Okay, Huygens principle. So this principle helps us to determine the position of new wavefront formed from the primary wavefront. Okay, so what is this primary wavefront? What is this secondary wavefront or secondary wavelets? Let's see now. Let us consider, first see the diagram, then I will explain the what is this principle is saying, right? So let us consider there is a point source, right? This point source, it will emit light in all possible direction. Now when it is emitting light, it is forming a wavefront like this. Okay, so that means the particles in this wavefront here, the particles in this wavefront, they are vibrating in the same phase at any instant of time. So as the particles are vibrating at same instant of time, so the particles in this line we consider to be as wavefront. Okay, and we know that rays of light, they are always perpendicular to the wavefront. Okay, now the particles which are in this medium, the line which I have drawn, it is in this medium, these particles will act as a new source of disturbance. That means this particle will also emit light in all possible directions. So now this is a source, it will emit light in all possible directions. Okay, so if it emits in all possible directions, so these are the rays I am making with arrow, right? All possible direction it is sending a light. Similarly, this ray will also emit light in all possible direction. This ray will also emit light in all possible direction. Okay, so like this, if we draw, then and we'll get a circle like this. Like this, these are the emission of light by each and every point source, right? So if I draw a tangent from here, then this is considered as secondary wavefront, and this one to be as primary wavefront. So primary wavefront forms secondary wavefront. Now the points, the particles which are in secondary wavefront, they acts as a new source of disturbance. So from here again tertiary wavefront will be formed. Again one line will be formed. So like this, source was one. Now this light is moving or is spreading in forward direction by forming wavefronts. Okay. So let's see what Huygens principle is saying. So according to this Huygens principle, every point on a given wavefront may be regarded as a point source of new disturbance. That means the point source which is in a primary wavefront, they are acting as a new source, they are forming the secondary wavefront. The new disturbance from each point is spread out in all directions. That is the new point, that means the light, suppose this is a point and it is in a primary wavefront, this is acting as a light source and it will emit light in all possible directions. Okay. So with the velocity of light, so when it is emitting a light, when this point source, each and every point source, when it is emitting light in all possible directions, that is of the velocity of light. Okay. The surface of tangency to the secondary wavelets, that means the surface of tangency means here the tangent, this line, the curve which we make by touching the tangent of these surfaces. Okay. So this one we consider as secondary wavefront. Okay. So the surface of tangency to the secondary wavelet is in forward direction at any instant gives the new position of wavefront at that time. So these are the principles of Huygens. Okay, so it gives the position of the formation of wavefront, and by knowing it is present position. So now this is the secondary wavefront or wavelet. Now when its particle will act as a new point of source, so again tertiary will be formed, again fourth will be formed. Okay, like this light moves in always in the forward direction. Intensity of light depends upon amplitude. Like I is directly proportional to A square. Intensity, how much light is moving in the forward direction. And this amplitude, it is based upon the formula 1 plus cos theta. Okay, now think, if theta is 180 degree, cos 180 degree is what? Minus 1. So 1 minus 1 will get 0. That means amplitude will be getting as here 0. So therefore light always propagates in the forward direction. Okay. So 0 degree, when I write here 0 degree, that means light is moving in the same direction. So cos 0 is what? 1. So that time amplitude won't be 0. But if I substitute here in place of 0, that is 180 degree, then we'll get here minus 1. Cos 180 degree is minus 1. So 1 minus 1 will get 0. So the propagation of light is always in the forward direction. Okay, not in the backward direction.